Hello students, welcome to all of you in my YouTube channel. I am Dr. Himanshu Sarkar. In my last lectures, physics class for class 12, I have discussed electric field, intensity, potential, dipole oscillation, end-on position, intensity, broadside position, everything I have discussed. Today, I will discuss what is the relationship between the electric field intensity and potential. This is very much important. Before that, I request to all of you to subscribe my channel so that all of you can get all my channel contents. Now, I told you what is intensity and what is potential in my last few lectures I have already discussed. Now, I will discuss relationship between electric field intensity E and potential V. Relationship between the intensity and the potential V. Now I consider here is a charge Q. Here is a charge Q. This charge Q gives some electric field whose intensity is what? E. Here I choose 2 points A and B. Here electric field direction is what? E. That is due to this charge Q, intensity direction is this. A2 intensity direction is E. Now, one thing, you know the potential definition. That is, it is the amount of work done in bringing a unit positive charge from infinity to a particular point in the electric field created by other charge. Already I have discussed in my last lectures. Okay. So, now I bring a charge, suppose Q0, from infinity to this point. So, let us consider potential at A is V and potential at B is what? V plus dV, and the distance AB is dx. Potential at A is V, potential at point B is what? V plus dV. So V is what? Potential at A, and V plus dV is what? Potential at B. Q0 is what? Q0 is a test charge. Now note one thing, you are bringing the charge Q0, test charge, from infinity to the point A. So the potential is what? V. Similarly here potential is what? If you bring the charge to B, potential is what? V plus dV. Okay. So 2 points A and B has been created with potentials V and V plus dV. So difference of potential is what? dV, and distance of AB is what? dx. Okay. Now, as electric field in this direction, what is the force on Q0 at A? Force is equal to what direction? This direction. That is the force. Force is equal to what? Q0 into E. As Q0 charge is placed at point A, so force on the charge is what? You know, force from the Q into E is electric field created by the charge Q. So what is the force? Q0 into E. So force is functioning along this direction because intensity is along this direction. Same direction of intensity is force direction. Now if we move a charge particle Q0 from A to B, now move charge Q0 from A to B. What will happen? We have to do some work done. Why work done? Because the force function is in this direction, you are doing work against this force, against. So what is the work done? So work done that is equal to what? Work done is equal to Q. Actually, you know, work formula is equal to what? Work formula is equal to F dot dx. Dot product. F dx cos theta. F is what? F is Q0e distance dx into cos how much angle? This is the direction of force. You are moving from here to here. This is a force and you are moving from here to here. So angle is what? 180 degree. So cos 180. That is cos 180 is what? Minus. So work done, you write down the work done as dw. So dw is equal to minus q0e into dx. Why minus sign? Cos 180 value is what? Minus 1. Okay. As cos 180 is equal to what? Minus 1. You know what is the work done? Moving charge from A to B. You know dw is equal to what? I write down this equation is suppose 1. dw is equal to what? Charge q0 into potential difference. Potential difference is what? That is V plus dV minus V. Work done is charge into potential difference between the 2 points. Okay. So we can write down. So I can write down VV cancel out. So that is Q0 into dV. That is equation number 2. So from 1 and 2, I can write down from 1 and 2 minus Q0 E dx is equal to Q0 dV. Q0 cancel out. So E is equal to what? Minus dV dx. This formula is very interesting formula, very important formula. E is equal to what? Minus dV dx. Note one thing, intensity is a vector quantity, but potential is a scalar quantity. So now, if we consider vector relationship, then E is equal to what? I write down E vector minus I cap dV dx. Here I assume V function of x alone. Here we assume V function of x. But if V is a function of both x, y, z, three-dimensional space, so I think students up to this clear to all of you, no problem. Okay. So if V is a function of x, y and z, then vector E is equal to what? Minus I del V del x plus j cap del V del y plus k cap del V del z. Here I am considering del operator because partial differentiation. If V is a function of x alone, I consider d. If V is a function of x, y, z, then I should consider del operator, partial differentiation. So I think students, all of you clear, it is a no problem. So E is equal to this. Suppose we can do some numericals, very much important for your IC exam, CBSE exam. Suppose we consider V is equal to 5x square plus 2x. Let potential 5x square plus 2x. Calculate question. Calculate electric field intensity at x is equal to 2. This is a question. Suppose. How to solve? You know V is this. E is equal to what? Minus dV dx. That is what? Minus d dx of 5x square plus 2x. That is what? Minus 5 d dx of x square minus 2 d dx of x. That is what? Minus 5 into 2x minus 2. That is minus 10x minus, plus 2 this. For x equal to suppose 2, then E is equal to what? Minus 10 into 2 plus 2. I think students, clear to all of you. I am stopping my class here. Thank you.